Hello everybody, do you hear me? I am Yair and I will be with the presentation today. I will be your presenter today. And today we are talking about the new PTO utility. Okay. Unitronics Unitronics has a PTO utility and has had a PTO utility and capability for quite some time, but today I'm presenting to you a new model, a new ladder model, which makes the PTO much easier, the configuration and using the PTO much easier, and it is way more advanced and contains a lot more functions. Okay, so what do we need the PTO for? First of all, we need it to control stepper motors and frequency converters, along with servo motors. These devices, they need a special functionality from our PLC, from our controller. Other devices that we use or Okay. Let's see. Okay, let's see the history of Unitronics' way to PTO. Okay, the first step of PTO, which was the simple high-speed output. The very early PLCs from Unitronics, they contained high-speed outputs, which worked in frequencies half a kilohertz, and the NPN, which is 60 kilohertz. This PTO, it could be controlled with it has control on frequency and duty cycle. Now every PLC with transistor outputs contains this simple high-speed output. This was the very first attempt of Unitronics PLCs to control a high-speed output. The second step was much more advanced, and it was implemented in Vision 130, 350, and in several snap-ins. This high-speed output, which controlled the PTO, it already had a frequency of 200 kilohertz and 60 kilohertz if you use the snap-in. The advantages of this PTO were that the pulses could be counted, and the target therefore could be set, and you could reach a precise stop after a predefined number of pulses. Now, setting the acceleration and the deceleration times was conducted via the ladder. you had to program the ladder so that on a certain pulse the PTO will stop the pulses.
Just 1 second, excuse me to interrupt. We see there are some questions. We'll answer all of them. You can, of course, you can pose your questions every time during the session, during the webinar, but we will enter and we'll answer all the questions one by one at the end. Thank you. Thank you for your understanding. We are continuing. Thank you, Yair.
Okay, so I'm talking about the second step of the PTO of Unitronics PLCs. Now, one more thing we could control via the ladder was the direction of the movements, but it was all performed from the ladder. Now I'm reaching the subject of our webinar, of this presentation. The subject is the third step, which is the ladder utility PTO. This is the most advanced attempt to create a full PTO, a real and full PTO. This is a PTO which is based on ladder modules. It is very easily and friendly and user-friendly to program, and it is way more advanced than all the possibilities that Unitronics has previously had. The first feature of this of the PTO is that you can use either pulse only, or pulse and direction, or clockwise and counterclockwise. What I mean is that the PTO, it uses two outputs, and one of them can be used for pulse, the other for direction, or you can use one output to the clockwise pulses and the second output to the counterclockwise pulses. The ladder models for all operations, they are very easy and intuitive to program. They are all performed from the ladder itself. The work is in engineer units. What it means is that if so far the working with PTO was performed with pulses, it means that the target was set in pulses, and the pulses were counted for all the calculations. And in order to set let's say a length or a number of cycles in a motor, you had to calculate it yourself with an external, without any connection, with no relevance to the ladder. But what we're doing now is we have a calculation within the PTO module. So you can pre-calculate the ratio between the length that you need to control and the number of pulses, and you set this ratio once, and once you set it, you can control the PTO using the engineer units. You can enter centimeters or meters, and the PTO will do the calculations itself. One more thing, one more feature that the new PTO can do is to control the jerk factor. The jerk factor is the intensity of the curve. It means that it can either be very smooth or very jerky, and it can be set in 16 steps, from a full trapezoid to a smooth S curve, totally smooth and sleek S curve. And that can be decided in 16 steps. One more thing is that you have both absolute and relative targets. It means that you can either control the movement in an absolute terms or relative terms. In absolute term, it means that you have let's say a length, and you need to, and you tell the motor to reach a certain point on that interval. And if you want to move relatively, it means that from where you are now, you want to reach a certain point relatively to where you are now, but not relatively to the entire length that you are controlling. One more thing about the PTO that you need to know is that it controls the movement in an open loop. It means that there is no feedback to the movement. What it means, the functionality, it depends on the control itself. If, let's say, you tell the motor to move 100 steps, there is no feedback. You don't know if it really did the 100 steps. You can only tell it what to do, but you don't get any feedback back. So in order to perform closed loop functionality, what you need to do is to use external devices. But the PTO itself does not do that. One more thing you need to know about the new PTO is that it controls each axis by itself. There is no linkage between each axis, between the two axes. This can prevent you from let's say drawing a circle, because you can tell the PTO to reach a certain point, but the way it reaches there is not, it can be decided, it's not definite. It can either, let's say you want to reach from A to B, the way can be, it can be a straight line, it can be a curve. You will reach the last, you will reach the last, the last point, but there is no way to know if how exactly this the movement will be. Now we want to go over the models. The first model in the PTO is the configuration. In the configuration, you need to first decide how many channels you need to use. The first, you have three channels, and you need to decide which ones are active. First of all, you choose the appropriate model, because not all models of controllers can provide the PTO functionality. Only 2 models provide it. This is the V130 and the V350, and these are the models that can provide PTO functionality. After you choose the model, you need to choose the channels. Now each channel, as we said before, each channel can have 3 options. The 3 possible modes are 1 pulse with no direction, or pulse with direction, And the last option is clockwise and counterclockwise. So each channel contains two outputs. After we defined the channels, the three channels, we defined two operands, one memory integer for the status and the success bit for the feedback of the configuration function of the model. The status can be the status can be that the configuration went successfully, or that there's something went wrong. It can be the full list of statuses is in the help file, but it is the usual messages, such as that wrong values were entered. Okay, I'm going back to the three channels. Three channels, we said that they can contain either pulse and direction, or one output for clockwise and second output for counterclockwise. But there is a certain combination available for the three channels, because not all three channels can be defined to do all three possibilities. What I mean is that for the first channel, if you choose pulse and direction, then I'm looking at the example, at the second example, the second from the left. If you choose pulse and direction, the second channel can also be pulse and direction, but then you cannot use the third channel. If you only choose pulse for the first channel, then you can also choose pulse for channel 1 and 2. Let's see the other possibilities. The third possibility is pulse and direction, and then if you choose pulse for the second channel, you cannot use the third channel. Again, the fourth combination is pulse and direction, and pulse. And the fifth, is clockwise, counterclockwise, and then the second channel is disabled, and the third channel can only be pulse. Now you see in the table, you see that there is the output numbers. These are the actual output outputs, the physical outputs. It means that there is no much flexibility in the output when choosing the output. It means that if you're choosing the first combination, you have to use output 0, 1, and 2. If you're using the second combination, you have to use output 0 and 2 for the first channel, and this is the physical output. Physical output 1 and 3 for the second channel, and so on. So when using the PTO, we have to follow these instructions. They're all listed in the help file. This is the profile setting PTO module. After you configure the PTO, you configure the channels and you choose the outputs, you need to configure set the PTO profile. The PTO profile, it contains the actual values for the PTO movement. let's say, the maximum velocity or the minimum velocity. The minimum velocity is the velocity in which the motor starts running, because a motor, stepper motor, doesn't start to run until a certain input of speed, of velocity. So these are values that you can get from the datasheet of the motor itself. This is not related to Visilogic. It is related to the motor that you're using, that you're controlling. And so first of all, the first value that you enter this module is which channel you want to control, because as we saw before, there are 3 channels, and for each one you can define a different profile. So you choose the channel, then you choose the start-stop velocity, which you get from the datasheet of the motor. You also enter the maximum velocity and the acceleration time and the deceleration time. These are times that you get from the motor datasheet. Again, if you choose an acceleration time which is too small, you will see that not all the time the motor will be able to follow these values. And the same goes for the deceleration time. As we said before, the PTO function can control the jerk factor. You can see here that the movement can be decided to be from a full trapezoid to a smooth S-curve. This is decided in the value, the F value, which is called the jerk factor. You enter these are the inputs that the function, that the model requires, and then the output will be, again, status and success. Status is a memory integer and a memory bit for success. Again, the status can be, it varies from, it can be a number of, there can be a number of statuses, and they can be wrong values, or that the configuration of the channel was not performed successfully. And again, the full list is in the help file. Okay, after we configured the channel and set the profile of the movement, if we want to start the actual movement, we need to use this module, which is called PTO move. What we need to enter this module is, first of all, which channel do we want to control, because we have 3 channels. And with the second input is the movement type, which is either absolute or relative. We said that absolute movement is when we know the exact position on a certain interval. If we don't know the exact position, but we know where we want to be relatively to where we are now, where the motor is right now, we use relative movement. So that is decided in the PTO move module. The next thing we decide is the velocity. Now, this is not the maximum velocity that the movement profile can provide, but it has to be inside this range. Okay, because cannot set velocity for a movement that exceeds the maximum velocity we set in the profile. Okay, the next input is the target position. The motor runs in when it gets pulses. We need to tell him how long or where to get when we want to move in our movement. This is where we put this value in the target position. Now these 4 inputs, they give us a movement. Again, as an output, we get a status and a success bit. If the movement was not performed successfully, we look at the status operand and we see what went wrong. Of course, when the PTO starts to move, the output that we chose in the channel, they start to function as well. It means that this is not an output that we see here. We don't configure or set it here, but we set it when we chose the channel in the configuration module. So we don't see it here, but it's still functioning. When the PTO is moving, when the motor is moving, we want to be able to control it and to monitor it. How do we do that? That's why we have another PTO model, which is called the PTO read status. The PTO read status model gives us all the information that we need to know about the movement of our device, either a motor or elevator, whatever. We get all the information from the PTO read status model. The input that it needs in order to give us the information is only the channel number. We enter the channel number and the model gives us all the information. The first piece of information that we get is the current position. The current position is something that varies during the movement. It changes during the movement until it reaches the target value that we set before in the movement model. The current velocity. The read status module gives us the current velocity of the movement. For instance, if we want to know if we are in the acceleration or the maximum velocity, we can monitor the velocity using this operand that we set here. Now, the motor has two directions. It can go either clockwise or counterclockwise. In order to monitor this, we have this memory bit, and it gives us the 2 options, either clockwise or counterclockwise, or back or forth. It's depending on the configuration. We have another memory bit which we might find useful. It's called the PTO read in progress, and if we want to make a condition, to create a condition that is regarding the PTO movement, we can use this memory bit as a condition. As with all the other modules, we have a status and success, which gives us the rest of the information that we might need about the movement. PTO provides us is the set home. Why do we need to set home, or what is set home model? We need it with the set home model can be used in two ways. If we're using absolute movement, we want to set the 0 point of the movement, and all the points and positions that we set from then on will be related to the home, to the 0 point of the movement. Then after we set the 0 point, we can tell the motor to get to position 100 or position 1000, and it will know where to go related to this 0 point. If we're using a relative movement, when we set the point home as home, we're telling the counter that to count from 0. What it means that if we set a target of 1000 and we set the home at the same time, the movement will reach 1000 pulses and will stop. But this is only for us to monitor the movement. It has no relative relevance to the control. How do we use the PTO set home? We first choose the channel, then we choose the offset. What does it mean to choose the offset? For certain applications, we don't want to set the 0 point, but we want to set, let's say, the 100 point. Okay, if the motor is at the moment at a certain point, and we want to say that from this point 100 pulses away, that will be the home point. So that's what we need the offset for. Again, we have the status and success bit to provide information about this model. I will now start to demonstrate how to use the PTO models in Visilogic itself. Let's start a new application. And as we said, we need to choose the correct PLC, which contains the PTO functionality. Now, I want to emphasize that we don't use or don't configure anything in the hardware. Configuring something in the hardware configuration window, it will be ran over by the ladder models that we will create later. So when we're using the new PTO models, there's no need, and it's actually forbidden to configure anything in this hardware configuration window. We only choose the correct PLC. After we chose the PLC, the first thing we need to do after we chose the PLC, the first thing that we'll do is to configure the channel. Configuring the channel is done only once. It is performed once. So I will choose the power a bit as the condition. Now the PTO is under utils, and I will choose the configuration model. Here is the window that we saw earlier. I need to choose which model I'm using. This is the one I have. And I need to decide which channels I'm using and with which combination. Since I only want to demonstrate the PTO functionality, I will choose only pulse and direction. Pulse and direction requires two outputs. As we've seen before in the combination table. Now, what do we have here? If you remember, if you recall, I said before that one of the advantages of the new PTO is that it can work with engineering units and not only with pulses. This is where we configure the engineering movements according to the pulses that the PTO provides. Okay? If, let's say, we know that 1 meter requires 100 pulses, and we want to work with meters, then we will choose 1 meter here. We will choose a memory integer which will contain this information, and we will say we will choose another memory integer which will contain the value 100. And in this case, way, we are deciding how to work with the PTO. For the example, I will choose 2 operands, and let's decide already to work with a very simple example that the ratio will be 1/1, just to make it more simple. I need to choose 2 operands for the status message and for the success beat. This is how you configure the PTO channel. Let's connect it and move on. The second thing we need to do is to set the profile. I chose the module of PTO set profile, and then I have to choose the values. First of all, I need to choose the channel. Since I chose before channel 0, I will also choose it now. Second input I need to enter is the start and stop velocity. As I told you before, the start-stop velocity is something that you get from the datasheet of the motor. It is something that is related to the device itself and not directly to the PLC. Let's decide of an arbitrary value. I will choose 100. Now, the maximum velocity. Again, as we said before, it is something that is related to the motor and the functionality of our project. The maximum velocity, for that I will choose an operand, which I will be able to change later. Acceleration time. The time here is in milliseconds. So let's choose an arbitrary value, and the same value for the deceleration time. Now the jerk factor. Again, between 1 and 16, we have 16 levels of jerk. Let's choose a jerk factor and operands for status and success bits. Again, I need to create a condition. Let's call it set profile condition. And I will also create another condition for this model, because maybe I will want to change it later, but not only on the power up bit. Oh, right. So this I will make a positive transition, and I will also use the power up bit. After we configured the PTO channel and we set the profile for the movement, the next thing we will want to do is to create the actual movement. Again, we have the model for that, the PTO model. The PTO move, I will place it somewhere in the next net. We'll have to choose the channel number, the type of the movement. For our demonstration, I will choose relative movement. I will use an operand for the velocity, because as we said, we can choose a different velocity for each move. Each time we call this module, we call this function, from the letter, the PTO will create the movement, the same movement as we are creating now. Now, after we chose the velocity, we will also want to choose the target position. How much movement, how long will the movement be? Again, I will choose an operand for this, and an operand for status and success bit. Now I set the movement, and I need to create a condition for that. I will choose this memory bit. I will call it move. And I will connect it later to a button on the PLC. In order to create a movement, what we've just done should be enough. But if we want to also stop the movement in the middle of the profile, we will need to use another model called stop. Again, I'm choosing the channel, the appropriate channel, and now I have two options to stop. I either have the normal stop, which the normal stop uses the value of in a certain time the PTO stop will use the same values. If I choose the immediate stop, this actually should only be used in emergency cases. In emergency cases, if we want to stop the movement immediately, without taking into account any consequences, we choose the immediate stop. Now, in stepper motors, immediate stop it's not a real thing, because immediate stop cannot be performed with a stepper motor. Once you stop giving it entering pulses, it will continue to move. So this is a very delicate decision to make to the stop module. Again, I will need to create a condition for the stop. I will later connect this condition to a button on the PLC. In order to monitor our movement, I will want to use the read status profile, read status model. I will place it here, choose the channel, and I will choose all these operands for the data. Now this model can be connected directly to the rail because we want to get the information all the time. We can, of course, use a different condition. You can use a condition to set the read status model only when the movement has started. But I will, for now, leave it connected to the rail. Now, I will go to the HMI and create a few buttons. First button will be for the movement, to initiate the move. We'll have to connect it to the memory bit I chose before. And I will create another button, second button, for the stop. Again, I need to connect it to the appropriate memory bit that I set before as a condition to the model stop. So I have two buttons, but I will also want to observe the movement, to monitor the movement on the PLC HMI. So I will take a numeric variable, and I will link it to the read status function that we set before. Let's see. Here we have the current position. Oh, might be different. Current velocity. Here, it is a double word operand. And that is everything we need to configure. Now, when I start the movement, I will see the velocity here. Let's also see the position of the movement. I'm choosing now the appropriate operand from the read status module that I said before. Here, that is all we need to create a movement and to monitor it in the simplest way to perform this. Now, all I have to do is to download it to our PLC, and let's see what happens.
One second, we are just changing the computer to be able to
Download the application to the PLC.
Okay.
Okay.
Okay. Okay. Right. Okay. Mute. Okay.
Okay. Do you hear me?
Okay.
Okay. Okay. אז פשוט להוריד את מה שיש לי. לעשות דאונלוד?
תנסה להפעיל. תגיד שעשית.
Okay. Now I've changed computers, and on this computer I have an application that I created earlier, which contains, which is just more advanced, and it's more attractive to see. What I'm using here is the PTO configuration, the PTO set profile as before, but here I am also using the set home, and I have two movements. So this is just a little more advanced, PTO example. I have downloaded it to the controller, and let's see how it looks. Okay, so this is how it looks. I created two buttons for two movements, and here we can set the velocity for both movements and the position for both movements. This is the window, the field where we see the current position that I take from the read status model. If I click on settings, I can see that yes, I go into the settings, I am setting the profile of the movement, which I will not change at the moment, but I can change the profile from the letter or from the HMI, or even from the HMI, I can change the profile and control the movement this way. Let's go back. Okay, I would like to show you how it looks. This is a ruler, yes, that is connected to a PLC, which has the PLC has on it the application I just showed you on the Visilogic. This is the ruler. I will leave this here, and let's see how it works. This is the controller that is controlling the ruler. I will click on the first button, and as you can see, the ruler has moved. Now I will change directions. You will see that changing directions controls the position. When you enter a negative position means that the motor should move in the opposite direction. If I click on the second movement, I will see that the velocity was much slower because this is set to 1,000 pulses, and the second or the first movement is set to 2,000 pulses. That's the difference. This is 2,000 pulses for a length of 5,000, and this is a slower velocity movement. Okay, so this is how you control the PTO, and now I would like to know if you have any questions. If everybody understood everything and are ready to use the PTO from now on. Okay, and you'll hear me and keep answering the question. I was Yair, I was your presenter today.
Okay, hello. Hello, I hope you hear me. So there are some questions. I want to thank especially to Yair for this good presentation. I hope you liked it. And this is a very interesting function, really, which opens a lot of room for interesting application, things that previously was not possible at all, or was possible limited and with just making a large code in Visilogic. Now this is much better. Now I have here some question. I will try to answer. I have a question from Mark switch your microphone and or type me what exactly you mean by process following. Hi, hi Mark, do you hear me? Okay, meantime I will wait a question from Mark. Let me see, maybe. No, there is no answer from Mark. Okay, so okay, another one question from František. Hello, František. I don't understand the reason for config success. What could be wrong with config block of the memorize in program? Can you get to the end of the memory? There are not inputs from hardware of the drive. Yes, you are right, but there are some settings, and it can be because of wrong and proper settings, some conflicts in the settings, and that's why you will receive that the message that the config process were wrong, and you will receive the status message, which you can check in help and see what is wrong with the specific settings. So we are trying to make some protection which will not let you to put some wrong settings, but as sometimes the settings are indirect, we cannot protect all. And it can happen that when you download the application and change some parameters, something will go wrong. For example, you put a number of jerk which is higher than 16, or negative, or something like this. So it can be situation that something goes wrong, and in this case you will receive feedback that something really is not accepted, and with error codes you can get more information what is not so good. So you can debug your application and put there the right parameters. Is this answer okay? Yes, thank you. Now, is it any brand of stepper or servo driver can be supported? We are not aware of any specific brand, any stepper or servo driver which has pulse direction interface, pulse direction input, especially in NPN mode. If it is PNP mode, it can be converted relatively easily with add of one transistor or even one resistor, which I don't like too much, but it can be done. But usually, because it's faster, they use the NPN mode, and any such a driver with such a interface can be used. There is no limitation I know about them. We are using here another one question. I hope this answered the question. It was a question questions from 1 second. Was a once again. Yes, it was a question from Ho from Yertech. Thank you, Ho. Nice to see you here in our webinar. Now, what kind of motor we are using? Here for our demonstration, we are using stepper motor. But it's not a must to use stepper motor. It's a matter of driver, as Yair already stated, and I also just stated, if the drive has the interface for step, for pulse direction, or clockwise, counterclockwise, so it can be connected to our controllers. Let's see if we have other. it was a question why the NPN frequency is bigger than PNP. I answered on this question. Once again, the PNP transistor, in fact, it's a chip inside the controller. It's not a standalone transistor. It needs to drive, it needs to switch relatively high current, up to half ampere. And this means that it has some slew rate which is relatively long, so it cannot support high frequency. In NPN mode, in fact, the transistor inside the controller, it's switching much lower current, up to 50 milliamperes, and it it opens the loop to 0 volt. It doesn't not need to provide current. That's why it's much faster. That's why it is NPN and not PNP. I hope this answer. This is a question from Bruno. So he just left. I'm sorry. Okay. Any other question? Let me take a look. Mark, I still wait if you can tell me more about your question. I'm not sure I understand. Okay. Another question from Mark, following a set speed from an external encoder. Okay, the function, the specific function we discuss, the PTO is open loop. Yair already stated that. I am stating once again. So in general, the function pure as a function has no any internal modules, internal functions, let's say, the utility to perform that. This can be done anyway, but you need a little help with the ladder. So you can connect the encoder, you can compare this, you can check the speed of the we receive from the encoder. You can also check the position, and you can do two things. First of all, for example, you can set a PID loop, and then the output of PID loop can go to the speed. You can change the speed during the movement with the PTO functionality. So you can take this speed from, let's say, PID loop, and the PID loop can take as an input the data from the encoder. So yes, this can be done, but not as a built-in function, but as with a little help with the ladder. If you need some more information, example, call us on support@unitronics.com, and we will be glad to help you with such application. Okay, I hope this answered your question, Mark. If it's okay for you, if you have another question, I will be glad to help to answer you. Now, I have a question if this function can support open collector and line drive type. It depends if open collector, it means I'm not sure. I'm not sure open collector. I'm not sure. I'm sorry. If if the drive is issuing power, I need to see the spec of the drive to be able to answer the question now. I cannot answer immediately, but if you can send some spec of the drive you are inducted, if we can support it to support@unitronics.com, I will review and will answer you specifically. Okay, let's see if we have another questions. Okay. See. Okay, here, would you mind to email us the programming? I hope Yair will do it with pleasure. Okay. Okay, so this seems that are the questions we have now. Do you have any other question? You can switch your microphones, and I hope I will hear you, or you can type your questions and I will see them and will answer to them too. Do you have any other questions? Do you like this new functionality? I hope so. Okay, so if you have no other questions, I think we can close the session. I really want to thank you, all of you, of your participation to this session, and I hope you will use now this new function and you found our webinar interesting. Thank you again for your time and for your participation, and I hope we will meet again on our next webinar. Thank you.
היה קצת מלחיץ, מחר יהיה יותר טוב. מחר יהיה יותר טוב. היה קצת לחוץ. גם פעם ראשונה אני לא הייתי מוכן מבחינת...